Hey guys, we're gonna be watching one of video that I think you might want to see. So hopefully, yeah.
Hey there, welcome to Life Noggin. Death is a sad yet inevitable part of life. At some point, you will die, and there is some weird, kind of creepy stuff that starts to happen to your body. First off, after you die, Hey there, welcome to Life Noggin. Death is a sad yet inevitable part of life. At some point, you will die, and there is some weird, kind of creepy stuff that starts to happen to your body. First off, after you die, your body will start to get cold. In fact, every hour after you die, your body will get about 0.8 degrees Celsius cooler until it reaches room temperature. And meanwhile, your cells will start dying from a lack of oxygen since, your lungs are no longer working and your heart has stopped beating. But this lack of oxygen won't kill them right away. Instead, they will live for several minutes. And during this time, there are still chemical reactions occurring that produce carbon dioxide and increase the acidity of the cell. Enzymes in the cells then start to digest the cell membrane, causing the cell to break down and start leaking. And the enzymes that escape can go on and break down the other cells around it. Creepy, huh? And fun fact, when your muscles relax after you die, it may lead to you peeing or defecating if you haven't used the bathroom in a while. Anyway, later on, blood starts to spill out from broken blood vessels, and since it isn't flowing around your body, you will start to look pale. Now, if you're lying down, as you probably will be, the blood will begin to travel down thanks to gravity, and it will be settled in the lowest regions along your backside. And this will eventually lead to discoloration. About 2 to 6 hours after death, rigor mortis kicks in. When you are living, you are able to contract and relax your muscles at will. But with rigor mortis, after your cells have used up the last of their energy supply, the protein filaments allowing your muscles to move become locked in place, which is why dead bodies are so stiff. And this stiffness usually lasts for about 3 days. A few days after death, putrefaction begins, as the bacteria in your gastrointestinal tract will start to break down tissues and cells, liquefying your body and producing horrific smelling gases like methane and hydrogen sulfide. And with the production of gas comes the bloating of your belly. The gas pressure causes any liquids in cells and blood vessels to spill out, which may eventually start to leak out of your body. And sometimes the pressure is so great that the abdomen bursts open, which is definitely an image that will haunt my dreams forever. Thank you for animating that, okay? And since your body is smelly, it will attract blowflies that will lay eggs in your rotting flesh, leading to the birth of maggots within a day. These maggots feed on your flesh, attracting beetles and other insects. Boy, this is a beautiful episode. 20 to 50 days after death, a process called butyric fermentation begins as the flesh is removed and your body dries out, and the parts of your body touching the ground start to develop mold. Then over the course of years, all your flesh has been decomposed and is eaten by various insects and animals, and all that is left is your skeleton. So it's not a pretty process at all, and it sure doesn't smell nice, but it sure makes me happy that most of the time someone dies, their body is quickly disposed of, so no one has to witness all of that. But hey, at least the science is interesting, right? Death might seem scary, but sometimes it's fascinating. Head over to our friend Rob Dyke's channel to learn more.
But that suddenly changed as Matthew, with Jennifer in the passenger seat, for unknown reasons, crossed into the opposite lane and crashed head-on into a brown Volvo containing 2 passengers.
Thank you for living, and don't forget to leave your suggestions for future videos in the comment section below. We're gonna be making more of them, people. As always, my name is Blocko. This has been Life Noggin. Don't forget to keep on thinking.
Blech. Okay. Wait, what? Yeah. Okay. Let's watch this.
My business relies on brain power, caffeine, and bandwidth. Lots of it. My old provider was slowing us down. But switching? Who can afford the downtime? Then I heard Spectrum Business makes it easy. Our office never skipped a beat. And Spectrum Business even bought out our contract. Now we've got the best.
Hey there, welcome to Life Noggin. For a lot of people, Hey there, welcome to Life Noggin. For a lot of people, sleeping is a time of rest, and the most movement you do is the normal tossing and turning. But for others, sleep can be a time to aimlessly walk around the house, drive a car, or cook a meal, all without them being consciously aware. This is called sleepwalking, or somnambulism, and scientists are still trying to figure out exactly why it occurs. But what they do know is that it most frequently happens to children and occurs during the deepest stages of sleep, stages 3 and 4. This is your deepest sleep, where your brain waves are the slowest. In contrast, during REM sleep, or rapid eye movement, your brain activity is much more active, and this is the stage in which most of your dreams occur. And to keep you from acting out those dreams, your body's muscles become temporarily paralyzed. So it makes sense that most sleepwalking occurs in the stage other than REM sleep, since you can't really walk around when your muscles are not able to move. And by the same logic, sleep talking also occurs mostly during deeper stages of sleep. Now, since the sleepwalker is in a deep stage of sleep, it will be quite difficult to wake them up. If you try, they'll be really confused about why they're not in bed. It's not dangerous to do this, but be prepared to explain the situation if you do. But with all that said, why does sleepwalking occur in the first place? Well, one hypothesis is that people rise from their beds when their brain attempts to go straight from non-REM sleep to being awake, rather than going through the rest of the sleep cycle. And it's thought that something triggered this transition. This is the part that scientists are still not sure on, but they have a few ideas. As mentioned before, sleepwalking mostly occurs in children, so some scientists think that children are more prone to sleepwalking because their brains aren't yet fully developed. It may be that all of the growth hormones are triggering the kid to rise, but it may also have to do with inhibitory neurotransmitters. See, there is a neurotransmitter called GABA that stifles the brain's motor system. For adults, this neurotransmitter usually does a good job to inhibit the body's motion, but for kids, the neurons that release that neurotransmitter aren't fully developed yet, so their motor systems may still be active. And voila, this can lead to the kid walking around their house in their sleep, or riding a skateboard juggling chainsaws wearing a top hat. I don't know. Now don't worry, children usually grow out of sleepwalking as they age and their brains fully develop. But if sleepwalking persists into adulthood, it may be linked to a mental disorder like alcoholism or clinical depression. Most of the time it's not dangerous, but if it gets to be, you may want to seek out a doctor for help. So have you ever sleepwalked before? And if so, what did you end up doing? Knowing me, I would end up eating leftover pizza right out of the fridge, but that's assuming I can sleep at all. Hey Animator, can I sleep? Cool, thank you. Anyway, make sure you come back every Monday for a brand new video. As always, I'm Blocko. This has been Life Noggin. Don't forget.
Yeah, exactly. Why do we forget our names?
Dad, are you okay? Dad, I'm worried about you. I called Dr. Davis and he wants you to come in as soon as possible. Dr. Davis says heart failure is manageable.
I know.
Dad, are you okay?
I'm fine. Go back to bed.
Maybe you should talk to someone. Need anything? I think it would be good for you to talk to somebody who knows what you're going through.
Hi, I heard about your group and would like to join your next session. When is it?
You okay, Dad?
Jane, I'm scared. You can do this. You've made it through worse.
to Life Noggin. You may think that since I'm merely an animation, I wouldn't be able to dream, right? Well, you're wrong. Last night, I had a dream I had human-like facial features and wasn't confined to the screen of your computer, and I was able to explore the human world and look at all those fancy toilets. I mean, look at this weird thing. A lot of people can't remember their dreams, and it's kind of strange that we can't recall something we do every single night. We are asleep about a third of our lives and dream at least 25% of that time. Most of our dreaming occurs during a stage of sleep called rapid eye movement, or REM. In this stage, as the name suggests, our eyes move around, but the rest of our body becomes paralyzed. That may seem terrifying, but it stops you from acting out your dreams, which could have some serious consequences, like you falling off your bed or flying into the sun. But dreaming isn't limited to just REM. Dreams have been reported even when the sleeper had only non-REM sleep. And even if a person gets a normal amount of REM sleep, lesions in their temporal parietal junction and medial prefrontal cortex are associated with a loss of dream recollection. But luckily, most of us don't have that problem. So then why do we forget most of our dreams? Well, as we talked about in our video about why we forget things, humans are really good at filtering out information that doesn't matter. If something doesn't grab our attention or isn't essential to know, you don't remember it. Think about the stream of consciousness you have when you're making breakfast in the morning. Chances are you can't recite it back to me. Some scientists think the same is true of dreams. But perhaps there is a neurological difference between those who recall most of their dreams and those who do not. To test this, researchers studied the brain waves of both types of sleepers. They primarily studied alpha waves between 8 to 12 hertz, which are also present when you are awake. Interestingly, oscillations of these alpha waves are associated with inhibition, meaning that a decrease in amplitude would correspond to a release in inhibition and therefore increased excitability. So let's relate that back to our dreams. While the volunteers were awake, tones were played in their ears, along with occasional and random first names. Those who recalled their dreams 4 or more times a week had a more sustained decrease in their alpha waves compared to those who only recalled their dreams once or twice a month. In other words, the high recalling group had a deeper processing of the first names while they were awake. However, this difference was not there during REM sleep. Instead, the alpha waves increased, possibly causing the volunteer to wake up. In fact, the main difference between groups was that those who recalled their dreams often woke up more throughout the night. This led scientists to believe that the time awake allows the dream's information to be encoded into long-term memory, allowing the sleeper to remember it the next morning. More time awake, more time to store the information. Makes sense, right? But before we can say anything conclusive, we need more research. We are just at the tip of the iceberg when it comes to our knowledge about dreams, and my knowledge about toilets. What is happening there? Anyway, why we forget dreams is still not exactly known. So tell me, do you remember most of your dreams? And if so, what's the weirdest dream you've had?